Okay, so vector analysis, as we mentioned earlier, is a mathematical tool with which most of the electromagnetic concepts are expressed and best comprehended. And what we have also said is that we must learn its rules and techniques before we can confidently apply it. Since most students taking this course have little exposure to vector analysis, considerable attention is given to it, and therefore this chapter and then the next two, of course, will be dealing with vector analysis, calculus, and coordinate systems. So for now, we are going to work to introduce the concepts of vector algebra in Cartesian coordinates, but of course, other coordinates are going to be introduced in a later lecture. And we are going to start with talking about the vector quantities. The first one is the scalar and a vector. And a scalar is a quantity that is completely specified by its magnitude. And examples of a scalar are mass, time, distance, temperature, uh, entropy, electrical potential, population, just but a few of the examples of scalars. And a vector, on the other hand, is the one that is described by both magnitude and direction. And examples are velocity, force, momentum, acceleration, displacement, and electric field intensity. So what we are saying is that if you want to describe velocity, you must always mention the magnitude and the direction, or at least it always mentions those ones. It must always indicate the magnitude and direction. So that is these are the two quantities that you must always be sure that you understand the difference. Now, to distinguish between scalar and a vector, we customarily use an arrow at the top of the vector, so that I want to underline this one. We normally use an arrow at the top of the letter, such that the way we have written this A and this B, this indicates that that is a vector. On the other, alternatively, we use a boldface to indicate that again that a given quantity is a vector. So, like when you see something like this A and this B, that means we are dealing with scalars. With vectors. Now, a scalar is represented by simply a letter without any arrow or without the boldface. Now this thing has stopped highlighting. Okay, having said that, then we are talking about EM theory is essentially a study of some particular fields, and a field is a function that specifies a particular quantity everywhere in a region. And I think last time we talked about a field or electric field, and my tool is really not doing very well because it's hanging. Just a second. Ladies and gentlemen. Again, we have just introduced the scalar and the vector. I definitely believe that the amount of memory that is taken by the meeting is quite enormous. That's not allowing us to see the screen. Okay, finally it has come. Okay, so this is where we were. I was mentioning that last time we were able to see the concept of I honestly don't like this. This meeting is really heavy on my machine. So I talked about a charge Q1. My goodness, this is too heavy on us. Well, I think we'll get used to this slow response. Although last time it was not behaving like that. So I wanted to say that the charge is allowed by a field of electric, or the one that we call the electric field, and that is the one that we characterize using the vectors and to show the direction of the force that is coming from this charge, etc. So a field may indicate a variation of quantity throughout the space and perhaps with time. If the quantity is scalar, the field is said to be a scalar or vector field. And for now, let's just jump to what we are dealing with today, which is the vectors. So the next important item that we need to address is what a unit vector is. And a unit vector is the vector itself divided by its magnitude, such that we can say that having said that a vector has a magnitude and direction, the magnitude of A is a scalar, that is a fact we know. And then a unit vector A that we normally represent as this is, which is along the direction of the vector A, is defined as a vector whose magnitude is unity. So what we normally say is that we represent a unit vector as A being equals to vector A divided by its amplitude. And Patrick, Jaggy, and Esther, log out and log back in with your registration numbers as your names and full names and registration number. Carrying on, we normally indicate today, I can tell you this. If we want to represent a unit vector, this is how you represent a unit vector. If you are writing, you normally put a hat on top of the small a. This represents that this is a unit vector of vector A. So in typing, I've of course indicated it in boldface. This is bold. But in handwriting, you normally say that this is written as A with the subscript A and then a hat on top to indicate that that is a unit vector. They're saying that it is represented by a vector itself, which might be written with the arrow at the top, divided by the magnitude of A, which is a scalar. So that is how we have said that we normally indicate the unit vector. It has a magnitude of 1 or unity, and it is in the direction of the vector itself. Now, a vector in Cartesian coordinates may be represented by equation 1, 7, which means that these are scalars representing the component in each direction, which now may be represented by ax, which is a scalar, and then ax is a unit vector, ay and ay small ay in the direction of the y direction, and az scalar and the unit vector. So if you are handwriting this one, and I want you to notice that accurately, is that you should write it as ax, then ax as a unit vector plus ay cap plus az az cap. So that is essentially the way we write a vector using the unit vectors which represent the directions in the Cartesian coordinates. So if you are to represent that information now on a graph or in the coordinates, you definitely show that this is the unit vector ay in the y direction, the unit vector as you can see, each of these, just don't like the way this thing is hanging today, but we don't have an option, do we? It is hanging, I think it taking out of memory. We might keep on adjusting ourselves. Someone advised Dennis and Dominic to sign out and sign back with their registration numbers included. So I'm saying that you can see that each of these unit vectors has as a unit has a magnitude of 1. This is, if you were to say this is 1, 2, 3, and this is, sorry, 1, 2, 3. In the z direction, it is 1, 2, 3. What you can see is that each of the unit vectors has a magnitude of 1, but then each one of them is indicating the direction of z, of y, and x. So that is how you would represent the unit vectors in the Cartesian coordinate system. But then if you are wanted to represent a vector A in the coordinate system, and we have said A being a vector is represented by A in x direction. I really don't like the way this thing is hanging. My laptop is hanging today terribly. It's poorly responding. I am not able to. Oh, what happened? Stopped sharing the screen. Today you have challenges, I tell you. Today we have some challenges of challenges. Someone has said that I should repeat of the unit vector. I will do that right away. I have said that the unit vector, and someone has also said that whenever I try to illustrate, they experience weak audio signals from their side. Now I don't know how I can teach without illustrating. So because the idea is to assume that we are on a board. Unit vector, I think, can best be shown by this diagram. That unit vector is just a vector in the direction of a vector, but it has only a direction or magnitude of 1. So assume, I think I can give that example. Assume I'm coming from Nyeri, straight line to Nyahururu, and that is a vector that has a distance of 100 kilometers, and the direction might be northeast. I don't know whether exactly which direction that is, but if you are describing the vector from Nyeri to Nyahururu, of course you are conversant with Nyeri and Nyahururu, that is a vector which is 100 kilometers in distance and direction is northeast. So this might be represented by a vector A, which is equals to 100 with the in direction northeast. So what we can say is that we can describe this vector again as using a magnitude which is 100. So we say that A without an arrow at the top is the magnitude, and then the unit vector A in direction northeast with the heart is equals to 1 in magnitude, but the direction is northeast. So it is like a unit. A unit means 1 kilometer if you can take that, or 1 meter depending on your units. Therefore, this one in the direction of Nyeri to Nyahururu describes the unit vector, that when you multiply by the magnitude of the actual vector, you get the final vector, which is 100 in the direction of northeast. That is the idea of of the unit vector. I think that is clear. I hope Nyaga is now hearing better. So you are disconnected. Message can't be sent. It is unbelievable. So we move on, and I think my screen will keep on going back. I was explaining this concept, and I said that 100 kilometers from Nyeri to Nyahururu is described by a vector A that has magnitude of 100 kilometers and direction northeast, and 1 kilometer northeast describes the unit vector, whereas 100 kilometers describes the magnitude. Okay, so we are saying that ax, ay, and az are the components of the vector A in the x, y, and z directions. And the unit vectors ax, ay, and az are the unit vectors again in the same directions. So, for example, ax is a dimensionless vector of magnitude 1 in the direction of the increase of x direction of x-axis. The unit vectors ax, ay are as we have illustrated in this figure above, and the components of a along the coordinates x-axis are shown here. So again, this is how I was saying that you can now describe a using the scalar ax and the unit vector ax plus in the direction of ay you have the scalar ay and the unit vector ay, and finally in the top direction going to az you have az and az as scalar and the unit vector az. Okay, so moving on, we can now see how do we calculate the magnitude of a vector. Now assume we wanted to describe this direction from Nyeri to Nyahururu using a vector, and they are saying that it is like going northeast. North might be x, east might be y, and the going up might be z, or like the altitude might be z. So what we are saying is that we normally just get the magnitude squared. So we can say that a, which is the magnitude, talking about the magnitude of vector a, is going to be given by ax squared plus ay squared plus az squared. Then you find the root of all that. That gives you the magnitude. But now to find the unit vector of a vector A, you express the vector itself just the way you would express it using the scalars and the unit vectors, but then you divide the amplitude that you got up there. So when you find the vector divided by its amplitude, that gives you the unit vector. I'm hearing that you are lost again. That is what Eric is saying, and we can't hear you. I'm muted. Am I muted really? You can't hear me. My goodness.